Thanks. All right. So thanks for showing up. Thanks to FITC for having me again. I was in Amsterdam, and that was delightful. So I'm going to talk about my work, which this is basically the mission statement. It sounds really ballsy and sort of blustery, but in actual fact, it's just how it is. I don't do anything without, obviously without geometry, and I don't do any geometry without algorithms. And hence, I don't do any algorithms without code. So this statement actually comes from an artist statement. And if you know anything about writing artist statements, you know that artist statements are really only known for one thing, and that's that they're always pretentious. So when you're writing an artist statement, you're always like hating your own words, which is really quite terrible. But I try to sort of circumvent it by writing a very antagonistic and kind of semi-angry, semi-funny kind of thing. That's one of my strategies. So this was the major work in that exhibition. This is called Prime Hex, which is a piece that actually just uses prime number sequences to animate these fluorescent lights. And what was interesting to me is that, okay, so working with code, you have this sort of infinite potential of variation, et cetera, et cetera. But this is actually one of my strongest pieces, I think, even though this is completely deterministic and there's no real sort of, there's no potential for change. There's no attempt to make this sort of wonderfully fluid software piece. Instead, it is what it is, and it will always be the same, even though, most humans can't recognize those patterns. So my name is Marius, and I'm an ex-designer. And of course, being an ex-designer is a little bit of a joke because it's like you can't deprogram yourself that well. You're going to always be a designer to some extent, but I haven't worked as a designer for over 10 years. I dropped out of computer science after 1 year. That was back in the 90s. And there was nowhere I could go to actually learn anything about the stuff that I wanted to do, which was to combine computation and aesthetics. And as a result, I don't have a degree in anything. But I am a .com survivor. So I was a first-generation microcomputer kid. I had a TRS-80 Radio Shack color computer in '84, which is pretty, that's, in this scene, that's like, oh, cool, okay, you're fine. You didn't start with a Mac, okay, it's good. And also, like, when I see people like, oh, yeah, I remember when I got on the internet and it was like AOL Messenger, I'm like, that was late. So I have this, I promised in my talk description that I would go through over 1,000 slides, and I can promise that. That's why I'm talking really, really fast. But the main chunk of those 1,000 slides will be something that I call Shock and Awe, which I developed for I/O 2012, which I don't know if you know the conference, but I knew that there would be a lot of really interesting people there, so I didn't want to talk about my work. I didn't want to do, one of those talks where you're like, oh, and then I did this. So instead, I put all the work that I had going back to 1994 into one giant slide presentation and put it to a banging techno soundtrack. So I apologize to Jesse and Jessica and maybe Micah for having seen it before, but there's a couple of new slides in here, so just bear with me. So this is going to be 4 minutes and 23, and it might be a little stroboscopic at the end. Uh-oh. That didn't work well. Why didn't that work well? It worked perfectly a minute ago. Okay, I'm going to quit that, and I'm going to run it again. So let's see. When you try things, just before the break and it works perfectly, that's when you should be afraid. Okay, let's see, 1 second. I'm not going to do live coding, but see if this worked this time.
I want everyone to be honest with me, okay? I want everyone out here tonight that have ever loved and lost before to raise your hand. Let me see, it ain't no big thing. All right. Love it in. Throw your hand up in the air.
Make it loud. Thank you. That was a little more glitchy than it's supposed to be, but glitch is good, right? So everything I do is code. I don't sketch, I don't prototype, I code. That is my strength and my falling. It's great when everything is like in a well-controlled system with your computer that works perfectly. It falls apart if your technology falls apart. But anything that I do, any visuals that you see, any 3D objects, anything that I do, all comes out of software systems. So every system contains the seed of their own creation, the process that results in the final form. It also contains the parameter sets that generate specific outputs, et cetera, et cetera. and often it's created as standalone systems so that the system itself actually knows how to choose new potential configurations. That sounds kind of smart. It's pretty obvious when you start working with that kind of stuff. One of the first things that you'll realize when you start working with generative systems is the fact that there is any system that has more than 2 variables has an infinite number of outputs. The next thing you realize is that's actually not very significant because it's true of everything. So this is what my world looks like typically. The thing on the right is the output, the thing on the left is the system that generates it, and I have to be able to translate between those 2 systems in my head, or those 2 different modes more accurately. So it's all about how to express yourself through these code structures, and often the thing that you come up against is how do you create interesting organic behavior given a material that is completely inorganic, code and data basically. And that's the challenge, but actually that's where I like to be. I like to be able to sort of envision these systems and be surprised by them. That's ultimately the best thing. Oh, sorry, Jesse, there are brave posters in here. These were my very first professional outputs. You can laugh, but I could ask you, what were you doing in '94? I was doing this, at least. I bet you've seen something like it that was made yesterday, but I made this 20 years ago. And this was, of course, this is a big part of, you can't disown your roots. These are my roots. Yes, the sort of hyperbole, yes, the utopia, yes, the sort of naivete. I'll own it all. This was a virtual reality installation I did in 1996. So again, you Oculus fans. This is why I don't believe in Oculus, by the way. Because virtual reality is great on some levels, but it's also extremely limiting as a medium. And I would love to be proven wrong and see Oculus and whatever other virtual reality systems really, take center stage. But I'm just a skeptic. This is my website from '96. Okay, that does look like crap, I know, but I won't make that same joke. So those are my roots. So if you can just interpolate between those roots and the stuff that you just saw in that shock and awe section, that's pretty much where I'm at. So I'm interested in spatial gestures. I'm interested in kinetic gestures, any kind of generative grammar or system that will produce geometry gone wild. And aesthetically, the intersection between the organic and the mechanical is, that's generally where I live. And I hang out with architects because we think about the same things, but with very different parameters around what we do. So unpredictability is one of the main interests that I have, not in a sort of facile way, but rather in the sense that, given that all these systems are capable of producing outputs that I can't predict, how can I find those areas, those clusters of parameters that produce interesting outputs? Typically, you end up using computation as a search method. This is an idea from, if you know genetic algorithms, that's kind of what genetic algorithms are all about. It's the assumption that if you represent a system by a cluster of parameters, then you can use kind of randomized searches through that parameter space to find optimal results. But of course, with genetic algorithms, you actually have a kind of fitness evaluation. In this case, the fitness evaluation is me looking at the screen, clicking through, potentially thousands of images and saying, okay, that one, which has led to me being able to usually recognize good results within sort of half a second before I click to the next one. So quite often, even the simplest system will produce results that I didn't anticipate, and knowing when to follow that randomness, that is sort of, I think, the strongest point of this kind of practice. So yeah, so just to hammer it home, any system that even if you create the system and you know everything that's in the system itself, even if you coded it without any mistakes, and let's face it, who does? You will not know the true sort of potential of the system until you explore it. So I'll show you a few pieces. This is a piece that I actually did for Creative Apps for Absolute Exchange, which was a weird weird project. I won't really talk about the project. But so this is cracking. It's a strategy where you subdivide and kind of randomize polygon meshes. But again, here, these are actually three-dimensional forms, but I'm optimizing them purely for the two-dimensional kind of visual impact that they have. This is another kind of slightly faked form. This looks like a very complex network structure, and I'm actually pleased to say that Tim Berners-Lee actually used this in a presentation about the web, and he came up with it, so that's good. But this is totally fake. It's completely randomized, and actually it's full of algorithmic bugs. You see the way that the arcs kind of twirl? That's gimbal lock, if you know what that is. But visually it works pretty well. Again, this is a three-dimensional shape, but once again, I'm much more interested in how does it render as a two-dimensional surface. And I'm exploiting the moire effects that it gives. And this is where I'm at my most happiest, like finding these shapes, discovering kind of the patterns that are latent within the system itself. So whereas these are still images, this is actually an animated system. I won't show it in real time, but this is a system that actually has all the rules for how to manipulate itself and change while it's actually animating. And this, for a while, was like really my piece de resistance in terms of kind of explaining what it is that I'm interested in the world that my forms inhabit. The idea that you could literally see them be generated in endless variations. But I also work with data. But I don't work with data the way the data people work with data, because I'm not interested in the meaning of the data necessarily, and I'm certainly not going to presume to tell you something about the data that some MIT statistician doesn't know. So this was a project for Knight Capital Group, which was an electronic trading company, and so this is stock market data. This is actually a glorified stock price historical graph. If you take it instead of the regular kind of spark lines, if you wrap it around in a column and then dump a ton of them on top of each other, this is what you might get. So I'm interested in this as a kind of landscape of data, finding forms that are latent within the data and which are truly there, but they are not necessarily about what the data is in the world. So this is intraday buy and sell orders. The lighter colors are sell orders, and the darker ones are sell orders, the lighter ones are buy orders. And you can't quite see it. Maybe I have a better one later. But there's actually a lot of randomness in the last quarter of the graph, and that's because this is one day. And towards the end of the day, all the traders want to dump their positions. They don't want to sit on a position overnight. So there's much more price volatility towards the end. And that's a pattern that I didn't know about until I actually saw it. So, so these are the sort of big ones. Yeah, this is the kind of volatility that I speak about. So if you imagine that this goes counterclockwise, the sort of spikes at the end are actually caused by people dumping their positions and being much more willing to accept kind of random prices. And of course, we did a very expensive large-scale projection at a big golf resort in Boca Raton. And then the company went out of business 2 years later because they lost $400 million in 30 minutes. If you have a bug that's that expensive, you might not ever work again. So my original focus, as I mentioned, was software as an object in itself. Using the screen as the default output. Real time is the new black. No editing, no post anything. And the system must know how to perform itself. And to me, that was a very interesting way of sort of, really looking at this notion of code as a generative, aesthetic practice. But then at some point I realized that actually what I'm dealing with here is kind of the materiality of screens. So if the screen is the default output, then the work must always deal with the qualities of the screen. Which is fine. I mean, I worked with that a lot, and I've had some success with it. This was a 4-screen video piece called Electroplastique, which is a sort of evolution of a single idea, which is actually just a shape that's it's a totally ordered grid that gets deformed by these magnetic forces. And as they distort, they pick up colors and weight and become these sort of unbearably organic forms. And then I strip it back down to reveal that the topography of the data is actually still this very rectilinear grid. Then I did some, these are actually, funnily enough, these are dead pieces. How many here still use a Nokia phone? No one. These are J2ME applets, which works really well on an old Nokia. But maybe your local drug dealer has one. You can test them on that. Or maybe your grandparents. But I like these pieces. They're extremely naive and very simple. And they're appropriate for the screens that they're interacting with. So again, this materiality of the screen. But then you also have things like this. This is a piece for a museum in the north of Norway. And if you notice, they have like stripes and things. And that's because in this configuration, every pixel costs X amount of dollars. So as a result, they have actually customized the screen by actually stripping out pixels in certain areas where they're less important, like underneath the box. And there are also areas on the box that are higher resolution than other areas of the box. So when you're working with screens, you have to interact with what is the screen as a material. The screen is not a neutral output. Because this is what they actually look like, these pieces. They're very different, rendered the way that I would see them when I'm developing them, and the way that they end up on the screen. This is maybe the only example where it feels much more like this is kind of close to a true screen, or like a true representation of how the video originally was. This is actually just a screen test. This is actually not a permanent piece, unfortunately. This is a giant screen in Jakarta, and this was done with Standard Vision, which is a company that delivers content for these kind of gigantic screens. This was, at the time, probably not anymore, but this is like a 1,600 feet long screen, which at the time was the biggest. But in recent years, I've actually shifted away from the screens because of this sort of ambivalence about, how do you deal with the screen, and particularly if you move, if it's not on this kind of gigantic facade, how can you make it sort of satisfying in a personal space? If you're going to show it in a gallery, what kind of screen do you need to deal with there? No one wants to see an artwork look like this on the wall. That's usually pretty frustrating. So instead, I've evolved into working with 3D printing and CNC technology, and become much more interested in looking at the digital interface to the physical world and trading fluidity and animation for tactility and the fact that the object is there. The object is present. It is not shown through this sort of membrane of the screen. But of course, as a result of that, you're then dealing with coding materials, and the physical process becomes the final step of the algorithm. The 3D printer becomes the final thing that you kind of modulate with the algorithm. So in the case of high-end 3D printing, typically the white stuff that you see everywhere, the goal is to obscure any artifact and achieve kind of digital perfection, which sounds great, but personally I find it to be kind of just not very satisfying, because you get what you ask for. And that's exactly why I never did inkjet prints. If you just press print and get exactly what you see on the screen, there is no transformation, there is no resistance. So instead, I've been working quite a bit with MakerBot. This is old MakerBot. Now, as everybody knows, MakerBot has a bit of a checkered history recently, but I still like them. This was the original cupcake. And this was the first exhibition I ever did with MakeBot objects. And I didn't really know if these pieces were good enough to stand up on their own. So I call them studies. That's a cop-out you can do in the art world. You can call something a study, and it's like, okay, don't critique it because it's a study. But it was also the seriality of these objects actually made it into a sort of decent series. Because if you have a series, and yet again, another trick from the art world, if you have a series, then the piece is evaluated as a totality and not as the individual objects. And the MakeBot allows you to do that, because with high-end 3D printing, you're not going to send off just some random pieces just to test them out. But with the MakeBot, if you have it in your house, you will do exactly that. And one of the things that I realized for the MICbot was that, at least the bot that I had at the time, was prone to delamination, which means that objects kind of crack and split open. So I developed this algorithm to create objects that had no volume, or as little volume as possible. So this is a direct result of sort of figuring out optimal shapes for the technology in question. So again, just as I do with code, this is a case of finding objects or structures that are optimized for, if I consider the production process as actually part of the algorithm, this is then optimizing the algorithm all the way to that final step. This is the first piece that I ever did with 3D printing. This was 2007, which, okay, it's not 1996, but it's still, in 3D printing terms, it's old. And it did amaze me how an object changes, because, if this was a 3D rendering, I would never show it, because that's just too static and not really all that interesting. And I would also not just animate it, because probably it just wouldn't look really good. But as a 3D object, when, you force the viewer to kind of look down and really interact with this object, because it's also not very big, it's about that big. And it becomes kind of, jewel-like, or kind of, it's so intricate that it pulls you in there. And of course, this object couldn't have existed without 3D printing. And that's very much the point that I try to input into all my works, that this wouldn't have been possible without the technology at hand. So I've done a lot of these pieces as well. This is basically, I call these laser drawings. And I was working with a laser cutter, and I was thinking about what is the logic of the laser. Well, the laser is actually just a point. The point becomes a line because it moves while it's burning. And so as a result, it's kind of a perfect vector space. And in a computer, a vector space is always emulated through pixels. But on a laser cutter, it's actually kind of a real vector space. So I was interested in what could I do with this vector space, and what would be the material sort of consequences of that space. One of them is that if you see on the bottom right, it really cuts deeply where multiple lines overlay each other. So it becomes these very satisfyingly physical pieces. So I've ended up doing quite a series of this. This is also laser, but it's on aluminum. And the aluminum, of course, actually is anodized. So the black is actually a color that's placed on top of the aluminum, and then the laser strips it away so it becomes the metal color underneath, which ends up being extremely technical looking, and they're almost sort of impossible objects. I'm really scared to handle these when I do exhibitions. And these are plotter drawings. You can buy these click and cut sort of papercraft cutters now, but that you can stick just a pen on and you'll have a plotter. It's quite satisfying. And again, you can barely see it here, but you see that the lines are a little blacker towards the edges. That's because in interest of precision, it'll put the pen down and then slowly speed up, and then maximum velocity will be halfway through the line, and then it'll slow down again, which means that the drawing actually has pooling of ink towards each end of the line. So all these kind of parameters are interesting to me. And then I went one further. So I never touch my work. I don't do anything with my hands. I don't model, I don't draw. This is the only exception. So this is a series of wall drawings that are called Exploder. And they're based on an older piece in which this sort of polygonalization of a sphere explodes into these shapes. And they're projected from a single point. Yeah, so that's me touching my work. Only time. So these are actually all projected from a single sort of vantage point. Are we at 10 minutes? Okay, 5? Okay. 10? Okay, perfect. So it means that if you're at the wrong position, in terms of where the projection originally was, it will kind of break apart. You will see it wrong. For instance, you see that the door in the corner there now looks wrong. And again, that's sort of playing with the technology. Once you're projecting it onto the wall, then it becomes flattened into a 2D space. So we are at 10 minutes. Yes?
Well, 15.
15, okay, all right. 15 is ages. So this is probably the scariest object I've ever done. This is actually a very large piece. It's about 6 foot high and, what is that in feet? 2.5 meters across, so like, yeah. So this was all done in processing, and this is sort of the hubris of the coder. I did all of it. I did all the calculations in processing. I didn't use any kind of architecture tools to like really test it out. This is the cutting patterns for the CNC machine, and these are actually the pieces being cut. But we did, just before I was about to send all of this to the cutter and like waste like 15 sheets of plywood that are like, 4x8s. We did a test and we realized that actually the sort of edged or the angled slats that are in between the two walls were actually incorrectly angled because I'd commented out a single line of code which angled them, flattened them out before they were projected onto the 2D plane. So don't do that, kids. Don't be that arrogant coder. Test your shit before you send it to the CNC machine. But in the end, it was all happy families. This is a piece that I just finished and which I'm looking forward to write about because this is actually using data as a found artifact. So these are protein data structures. They're protein models. They're things from DNA, viruses, et cetera, et cetera. And this was for a public art piece for a school in Oslo. And so I was curious about this sort of scientific visualization style that we all accept, but we accept it without even necessarily knowing what it is. We just take it for granted that, like, this is a real thing, and scientists say that it is, so we'll believe it. But I was more like, okay, but what if I want it to look like the latest Chanel collection? So this is my Chanel Gucci reimagining of protein structures. And indeed, I apologize to any biodata people in the house because I've already been told by 3 different people that you can't do that. That is so wrong. And maybe it is, but it looks good. You can just about see that there's a DNA kind of structure going on here. I don't remember exactly what this is. But so I'm interested in, like the structures that are in the data itself. Like that's what we're all attracted to when we see these kind of, visualizations of bacteria or DNA, et cetera. Like there's a sexiness to it. And I have the same issue with architecture models because now kind of parametric architecture tends to actually show what they're going to do. But for a while, people who were working with parametric systems in architecture would like show you these amazing looking models, and then you would critique them on the basis of how they looked, but they will always cop out by saying like, oh, but that's just the model of the data, it's not the form. But of course, anytime you show someone something that's very sexy, you're implicitly convincing them with that sexiness. So, beware of shiny things, except mine. So this is actually the first iteration of the prime piece that I showed you very briefly earlier on. This was for a public art piece in a train tunnel, and that's a pretty hostile environment for art. It's also a hostile environment for viewing art. I had to walk through these tunnels where that's not me, but I was dressed exactly like that and was carrying a tripod and running around and trying to avoid the train. But it's a large-scale piece, and I chose the prime number logic because I wanted to make sure that it would never repeat in a meaningful way. Essentially, if you know prime number sequences that were used by electroacoustic musicians like John Cage, etc., where they would take tape loops that had, a duration that was a prime number, and then if you had multiple prime number sequences, they won't repeat until a time which is actually the length of all of them multiplied together. So it's factoring. And that means that the actual sort of total duration of this piece is about 180 days. And of course, you could technically get through that, but unless you're autistic, chances are you will not be able to predict what's coming next. So the light in the tunnel is indeed an oncoming train. All right, now we're at 10. So these are the different shapes of the prime hex version, which is the one that I showed you, the one with the lights, or of course it's with the lights, this one, which I thought was a pretty exciting version because I did this piece and it worked well, but I just realized that it wasn't, I just like the geometry of this one better. And also, another nice thing here is that working with a fabricator, he was able to just add these welded joints that just accentuate the geometry. They just kind of complete the triangles in a way that, of course, the lights won't, because they can't, but directly up against each other. So I was quite satisfied with this one. And as a consequence of this piece, I ended up working on a larger three-dimensional installation, which I'm working on at the moment for a cultural house in the north of Norway. And so imagining that you take the same logic, but you extend it to a 3D polygon wireframe, what could that look like? And of course, when you're looking, this looks like a simple low polygon structure from a sort of, 3D point of view if you're a 3D modeler. But if you're looking at it in terms of actually reproducing all these edges, then, suddenly that becomes quite a lot of, aluminum edges, et cetera, et cetera. So I reduced it down to a simpler structure and started modeling it directly. And of course, one of the problems you have is, so these yellow things are actually sort of meant to indicate where the lighting fixtures would go. And the problem becomes that you have to optimize the system for edge length. You have to actually guarantee that the lengths of the edges are long enough to contain these lighting fixtures, but also not so long that the lighting fixtures don't just become like a blip in the middle of it. And as a consequence, I was playing around with different structures, but I very quickly sort of realized that a lot of it ended up being really boring. And I was fortunate that I ended up playing with something called isosurfaces, also known as metaballs, which ended up giving me the right geometry and even somewhat optimized them for the edge condition. But it also looked like the landscape in the north of Norway. So I'm sure in Canada you have fjords, and you know that fjords are mostly made by glaciers, and the glaciers will kind of scour the mountains and kind of smooth them out. So you get these sort of smooth things that just stick directly out of the water, and that's what the landscape up in the north of Norway looks like. And as a consequence, that's what I wanted to make these shapes into, which was kind of interesting. I'm not really given to sort of having sort of flowery, nature, metaphors in my work, but in this case, it really was what I was trying to do. So these are kind of close to the final form that it will have. This is it in sort of modeled in the landscape of the building. So there will be two different blobs that will be coming through the space, and they'll be seen from different vantage points. And when you turn off the lights, that's sort of how it'll be. I mean, this is the north of Norway, so it will be dark a lot of the time. Very good for light installations. Let's see where we are at. Was that it? Am I actually at the end? I'm at the end. What do you know? Okay, well then we actually have time for Q&A, which I usually never do. Do we have 2 minutes, or we have 5 minutes? I went through 140 slides really quickly, huh? All right, any questions about, I could go back to the big slideshow if you want. You could ask me about anything in there. Come on, hit me with a question, yes.
Did you output geometry? What format are you
Typically STL or PDF. So STL is, like totally neutral, very easy to output. I have a library for it in processing. You can go and find that if you want. How many processing users in the house? Ah, good showing. So I have a library called Model Builder, which is directly intended for 3D printing, which I actually created for my artist in residence with MakerBot. So shoot me an email. It's not listed on the processing website, which is kind of bad, but I haven't pushed for it, partly because I realized the more I promote it, the more I have to support it. And who can afford that, huh? So ask me processing questions. I'll tell you all my tricks. Come on. You know you want to ask me something.
Sure. So you were talking about doing wave posters back in the 90s.
Mm-hmm.
What do you think you'll be doing in the, let's say, 2020s, 2030s?
Whoa, that's a long time. I can't tell you what I'll be doing in 2016. So, What would I like to be doing? I'd like to get paid. That sounds crass, but it's true. The weird thing, if you ask, okay, so I had this actually in the sort of what you'll learn, so this is a good moment. Why are artists desperate? Well, because half the time when I'm standing on a stage like this, not this time around, I'm pleased to say, I'm making way less money than you in the audience. That's actually just a fact. The value exchange of being kind of a thought leader in this kind of field, not a good deal. I don't advise it. I'll go on record and say, like, artists don't, friends don't let friends become artists. Unless you really need to, in which case I'll support you to the end of the world, but like, don't do it if you're not ready for it. But I mean, I guess that's no surprise. So, and I guess that's not a huge issue in this particular audience. But what would I like to do in 2016? Yeah, I'd like to do the same work and get paid. Yeah. Yeah, I do. Okay, so in 2005, I made a conference called Generator X, which was about setting down the flag for the idea that computational strategies for creative work was really a thing, because at the time it wasn't, accepted at all. Today it is. Today at this conference, no one would question that. But yes, my work is very much off the time that I make it in, because, of course, I'm informed by everything that happens around me. I'm not one of these people who follows technologies. At least I'm not anymore. I mean, I know I was hating on Oculus. That's playfully done. I don't actually need to hate on Oculus, but I would hesitate to follow technologies, because technologies aren't solutions. Your ideas have to be the interesting ones. But for instance, in the field of data, what we're doing with data today is really significant to the human condition. Our current human condition is a digital human condition. It's a human condition of data. And if we can't deal with that and understand the technology that happens around us, we're going to be, well, out of luck. I would have said a worse word, but yeah. Yeah? I didn't. Processing was the only thing that existed when I started doing this. Cinder is, okay, so this is an interesting question that you get asked. So both Cinder and open frameworks are arguably kind of known as sort of more powerful tools. But if you ask Andrew Bell, who made Cinder, he would tell you that only if you spend a lot of time optimizing your code. C++ is not implicitly faster than Java is. It only is if you optimize your code correctly. So in my, I'll adopt new tools if I find a use for them. So I've actually taught myself Python the last year. And I know that's really late. I'm coming late to that party. And it's only really because I realized that yes, working with Python for certain tools does give me a 10% improvement, or 20, 50, 100%, whatever. So I won't shift to open frameworks or Cinder just to be able to do the same thing when I have tons and tons of old code that does a lot of amazing stuff. So I think that's true for anyone who sort of selects a tool. You do end up getting stuck with it, and of course there's a danger in that. But I haven't sort of come up against anything where I've thought shit, I really need to upgrade. We done? One more minute. One more question. Yeah. I've had students as okay, so I'm not actually the best coder in the room when I'm teaching. I teach at ITP in New York sometimes, and there at least I've had multiple times students who are much stronger coders, but they don't have an eye. They don't see their own work for shit. So I'll stop them and be no, that's good. This thing that's way more advanced doesn't even rate. Forget it. You're excited about the algorithm. It does nothing for anyone else. And that's a really sort of important point. You have to be able to let go of things because they're meaningful to you or they're advanced to you. Get rid of your God programmer already. It's not, if you're talking about things that other people will perceive, that's not going to rate. But for me, it's really, sometimes I'll see something that's really kind of a bug or a glitch, and I'll realize that that's way more interesting than my original intention. So, yeah. All right, that's it. Thank you very much.